Hello, tell me once if my voice is clear to all of you. Hello, hello. Tell me in the comment section if the voice is clearly audible to all of you. Hello. Tell me in the comment section. Okay. Voice is completely clear, so we are good to go. Just a minute. Okay. Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. So in today's lecture, what we are going to learn, okay, we have completed the reflection portion. We have seen in the first lecture, in the first part of this ray optics, we have seen about a reflection from plane mirror. Then in the second lecture, we have seen about reflection from spherical surfaces. In spherical surfaces, we have seen two cases. One was concave mirror, one was convex mirror. Magnification, mirror formula, all these derivations we have seen in the last class. For magnification was also of two types. One was transverse magnification, second one was what? Longitudinal magnification. What was transverse magnification? When you are keeping the object perpendicular to the principal axis, that is called as transverse magnification. And what is longitudinal magnification? When you are keeping the object parallel along the principal axis, then you are telling them that it is what kind of magnification? Longitudinal magnification, correct? So these are the basic two things that we have already studied. Now today what we are going to study is reflection part is over. Now we are going to focus on refraction. Now what is refraction and what was reflection? Reflection was what? When the light comes back again in the same medium. Let's suppose this is the surface that you have. For a moment, let's assume this is a surface on which light is incident. Okay, if light is incident at some angle, it will have some normal and light will be reflected, and we have seen laws of reflection that angle of incidence is equal to angle of reflection. So when light is coming back again in the same medium, it is called as this phenomena is called as what? Reflection. But if let's suppose light is incident and light is now transmitted to the, let's suppose here it is air, here it is some other medium. So when the light is traveling into other medium, then this phenomena is called as what? Refraction. That is what in this today's class we are going to understand. And of course, if there is a refraction, there will be some bending of light. So how we define refraction? The phenomena of bending of light. The phenomena of bending of light is called as refraction. So it will be bending, how that will be bending, how much that will be bending, how much deviation also we have seen in reflection also. So here also we are going to see the deviation. All these things we are going to see. Let's start one by one. So are you ready to learn something new? Be ready with your pen and paper. Okay, let's start without wasting any further time. See how it actually looks like. Let's see that also. And in the last class only I have told you about refraction, that whenever light is traveling from one medium to other medium, velocity changes. Velocity is dependent, and in this lecture we are going to understand in complete detail that how velocity actually changes. Wavelength also changes, but what is constant? Constant will be always frequency will be always constant. Okay, so that is the example that is shown here. If I will tell you, see, this is the incident light. Some of the part of the lights will be get reflected. This phenomena is called as what? Reflection. This phenomena is called as what? Reflection. And some portion of the light will be coming into the another medium and it will be bending its path. Can you say this was the original path that was going, correct? And now it has bent its path. This is called as angle of refraction. Called as what? Angle of refraction. And this phenomena is called as what? Refraction. This phenomena is called as what? Refraction. What will be constant here? You can see that here frequency is the only thing that is constant, and the rest of the things will be keep changing. Okay, so now why the light have bent only in this direction? Why not from the original problem? Why not in the away sense? Why this has happened? All these things we are going to understand one by one. Before that, tell me how many of you know about the laws of refraction? How many of you know about the laws of refraction? Okay, let's see about the laws of refraction also. But before that, I have to tell you very important, and that is refractive index. Refractive index is a material dependent property. So if it is a body, it will have its own refractive index. If I am taking some other body, let's suppose I am taking this remote will have its own different refractive index. So different body have their own refractive index. It is not anything like you have to calculate, it is already given. How it is defined? In exam perspective, you have to define it by like this way. And for derivation purpose, how you derive refractive index, understand here. See, C is defined as 3 into 10 power 8 is equal to 1 by root under mu naught divided by epsilon naught. In the last chapter, electromagnetic waves, I have told you are very important relation that you always write C is equals to 1 by divided by mu naught into epsilon naught. Clear? So if I will ask you, tell me what is the speed of light in a medium, how you will be writing? You will be writing velocity in a medium, let's suppose I am representing it by V, divided by, you will be writing mu into epsilon, correct? Mu naught is what? In vacuum or air we define, and for a medium, what I will write? Simply mu, correct? Mu of that medium. And what is mu? That is clear now. Mu is permeability and epsilon is what? Permittivity. So I can write also, because from electrostatics we are learning how to write this thing. Mu can be written as mu naught into mu r. Mu naught is what? Permeability in vacuum, and mu r is what? Relative permeability. It is what? Relative permeability. And epsilon can be written as epsilon naught multiplied by epsilon r. Epsilon naught into epsilon r. So further it can be written as 1 divided by mu naught into epsilon naught multiplied by 1 divided by, here it will be what? Mu r into epsilon r. Mu r into epsilon r. Now see, this multiplication of mu r into epsilon r is defined as what? Refractive index. Now tell me what about this one? This complete is what? Here it is already, I have told you this is equals to C. So what will be saying? Velocity in a medium is equals to, here it will become what? It will become C, and here this term, this multiplication will become what? This is defined as refractive index. This is defined as what? Refractive index. So here you will be writing N. So the formula and the representation point of view, refractive index is a lot of times also described as mu. So books, a lot of books is defining you refractive index as mu. So it's up to you. Either use N, either use mu. Okay. So it mu or N can be defined as C divided by velocity. This is the important result that you have to that, and from there also you can find any velocity. If you have to find velocity in a medium, what you will be doing? Velocity in medium, if you want to calculate, you know already the velocity in air, refractive index will be already given. You can calculate the velocity in the medium. Clear? Or refractive index, and also vice versa, you can calculate by the same way. Correct? So here are some refractive index are given to you that you have to remember. Anyway, most of the time it is already given into the question, it is always mentioned in the question, but still for reference you should be knowing, you should be remembering the values. Okay, for example, for vacuum always refractive index is 1. For glass you have to remember that it is 3 by 2 or 1.5 according to the question, you can use it. And water is equals to 4 by 3. This is the thing that you have to remember. Like here, what is this relation? If I have to tell you, what is this relation? See, N is equals to what? C by V. Correct? C by V. And let's suppose I am writing for some medium 1, N1. Let's suppose here it is N, light is going from N1 medium to N2 medium. N1 medium to N2 medium. So how I will be defining the things? I will be writing N1 C divided by velocity in medium 1. And C is what? C is constant, that is velocity in air. So that will be constant. I will be writing N2. N2 I will be writing as C divided by V2. C divided by V2. Now what you do? Take the ratio. Take the ratio N1 by N2. When you are taking this ratio, C will simply cancel out. That is equals to V2 by V1. And what is velocity 2 can also be written as frequency into lambda 2 divided by frequency into lambda 1. Because frequency is same in both the mediums, I have already mentioned. That's why I will keep frequency as same, and I will be writing N1 by N2 is equals to V2 by V1 is equals to lambda 2 divided by lambda 1. Lambda 2 divided by lambda 1. So see, this is the same relation that is given here. Clear? Fine. Now, laws of reflection. Laws of reflection, first law and the most important law, that is Snell's law. That is what? Snell's law. You should be very, very clear about Snell's law. If you are clear about Snell's law, easily you can understand the complete refraction. Okay. Because every places you have to apply Snell's law. Whatever the derivations that we are going to understand is completely derived from only Snell's law. Every single thing. So let's understand what is Snell's law. Very simple law. What it says, N1. The law, if I have to write the equation, the law's equation is N1 sine of I is equals to N2 sine of R. Now what is these terms? N1, this is the refractive index of the incident medium. What is this? Refractive index of the incident medium. Now what is this I? This I, this is the incident angle. And incident angle, please remember, don't make this mistake. Incident angle is always calculated from your normal. From your normal to the surface, incident angle is always calculated from there. What is the next term? N2. N2 is what? Refractive index of medium 2. It is defined as the refractive index of medium 2. And what is R? R is called as refractive angle. So just you have to do N1 refractive index of incident medium into sine of I multiplied by is equals to M multiplied by N2 into sine of R. That means for refractive medium into the angle of refraction, sine of angle of refraction. That will be the result, and these terms you should be very clear. Anyways, we are going to solve a lot of questions, and from there it will be very simply clear to you what is Snell's law. Okay. Now, what are the laws of reflection? First law is Snell's law. Second law says that incident ray, reflected ray, and the normal all lie on the same plane. It should be refracted ray, refracted ray. All lies on the same plane, and it was same in the law of reflection also. So I hope that this is clear to you. Same for both the cases. Now, bending of light. About what I was telling you, that you have seen, sir, from the normal path that was going, why it only bent towards the normal? Why not away? Sorry. Why not away from the normal? Okay. Let's see. See, here it is the case. Firstly, it is bending of light due to refraction, and light is moving from denser medium to rarer medium. You are clear now about denser and medium. What is denser medium? Denser medium means a densely medium like water as compared to air, and rarer medium means N value will be lesser. That means I can say here denser to rarer. That means you are coming from some denser medium to rarer medium. That means N1 is going to be greater than N2. This is clear. Okay. Now let's see what will be happening. See, apply Snell's law. What will be writing? Ni sin I. That means you will write N1 sine of I is equals to N2 sine of R. Correct. This is the angle of reflection that you will be saying. Now, why that is bending away from the north? Just give me a moment. You will understand. Now, what you can say? N1 by N2 is equals to what? Sine of R divided by sine of I. Correct. Same thing I have written in different form. Now, what is the condition here that N1 is greater than N2? What is the condition here that N1 is greater than N2? If N1 is greater than N2, on the left side, can you say here also it is mandatory for sine of R to be greater than sine of I? Yes or no? Because whatever is happening on the left side, there is equality. That means it have to happen on the right side also. And can I say that angle of R, angle of refraction, should be greater than angle of incidence in this case? That means angle of refraction will be greater than angle of incidence. Now come to the ray diagram. Ray diagram, this is the normal I, that was incident ray that was coming. So if it is bending towards the normal, this is the normal. If it is bending towards the normal, angle of reflection will be less, because this much angle is what? I. That means angle of reflection have to be greater than I. That means it will bend away from the normal. So remember a statement, when you are moving from denser medium to rarer medium, bending is always away from the normal. Remember, this is a very important thing. A lot of time you are going to apply this. Okay, away from the normal. And now if I will ask you about deviation, deviation कैसे लिखोगे? See, This is the angle of incidence. That means what is deviation? Basically, I've told you that from the normal incident path, how much angle it is deviated, how much angle it have changed. So this was the normal ray that was going. The light ray have changed this much of path. This angle is called as deviation. How I can write this complete angle is r. This much angle is I. That means deviation. I will write what? R minus I. Always remember for this case deviation will be r minus I. Or simple words, remember that greater minus smaller. Who is greater? Angle of reflection is greater. Just subtract angle of reflection minus angle of incidence. That's it. That will be your answer. Correct? Very good. Now the next case. Next case also will be derived by the same way. No problem. See how you will be deriving this case. Light is moving from rarer to denser medium. This time you are moving from rarer to denser medium. This is the rarer medium, this is the denser medium. That means you will say N2 is greater than N1. Because Snell's law at this point. Right? Snell's law at this point. What you will be writing? Incident medium. Incident medium is what? N1. Sine of I is equals to this one, this medium. N2 sine of R. What you will be writing? Sine of I divided by sine of R is equals to N2 divided by N1. N2 divided by N1. Now what you can say, what you know already, the condition is that N2 is greater than N1. If N2 is greater than N1, can you say sine of I also have to be greater than sine of R? Correct? That is what I can say further, that angle of incidence have to be greater than angle of reflection. Or in other ways, I can say that angle of reflection is smaller than the angle of incidence. That means now make it again the diagram. It will be very clear to you. See, this was the normal ray that was going. Now you have two possibilities. Either you can bend, this is the normal, away from the normal like this way, or towards the normal. Now angle of incidence have to be greater. Angle of incidence have to be greater. That means this complete is what? Angle of incidence. This complete angle is I. That means your angle of reflection have to be lesser than that. If angle of reflection you have to make lesser than that, that means you have to bend it always towards the normal. That means what is the important point that you have to notice? That bending is towards the normal. Bending is always towards the normal. Clear? And now if I will talking about the deviation, I already have told you. This was the original path. Now this is the deviation that you will be having. Who is greater? And I've told you, not always do simply remember one thing, greater minus smaller. Do greater minus smaller. Who is greater? I is greater minus smaller, I minus R. That is what the deviation that you are going to take. Clear? That is what the deviation that you will be having. Now see, there is a question. Try to solve this question. It will tell you about the basics, that how to solve, how to apply Snell's law. Okay, it will be very much making clear to you. Try to solve this question. Read this question, what the question is saying. See, if a light ray goes from a medium having n is equals to 2 to medium n is equals to 1, actually it is going from n is equal to root 2. It is going from, in the question, either in the question there is a mistake or either in the diagram there is a mistake. Anyways, we will calculate from both the cases, no problem. Let's cross check it. Which one is coming correct? See, if a light ray goes from a medium n is equals to either root 2 or the 2 to medium having n is equals to 1 as shown in the, find the angle of deviation. Angle of deviation, how much it will be? Let's understand from everything perspective, that let's make the diagram also and let's solve it. What is the Snell's law? Ni sine I is equals to nr sine of r. Okay. Firstly, let's make the ray diagram. See, this was the normal incident ray. Correct. Now you are moving from denser medium to rarer medium. You are moving from denser medium to rarer medium means what? Denser to rarer, that means bending is always away from the normal. Bending is away from the normal. This is now either you have towards the normal, either away from the normal. I will go away from the normal. I will go away from the normal. This will be completely calculated as R. And now I have to calculate deviation. That means who is greater? Batao. Who is greater? R is greater. That means I will say R minus I. R minus I. That is what I have to solve. Now, but I have to calculate how much R is also present. So now put the values. I. Itna ho gaya yaar. I think that it is equals to 2. Here it is by mistake written. Let's see. I, if I am putting 2, let's suppose if it is 2 into sine of I, that means sine of 30 is equals to NR, refractive medium 1, into sine of R. That means sine of R will be written as 2 times of sine of 30. Sine of 30 is half, cancel, it will become 1. That means R is equals to how much? 90 degree it will be coming. And how much deviation you will be saying? Deviation is higher minus smaller. That means 90 minus I, that is 30. Answer will be 60 degree. And in which sense this deviation is coming? This is the, now this was the original path from here to here. That means it is 60 degree in anti-clockwise direction. Okay. And let's suppose the value is given as root 2. तो उसके लिए भी कैलकुलेट कर लो क्या चेंज आएगा. Here only it will be root 2. In case I am telling you about if the value is root 2, then what will be the answer coming? Here it will be root 2. Here it will be 2. So you will be having root 2 sine of root 2. No, that means it will not be coming as a standard angle. So answer will be this same only. Correct? Correct. Next one. This is also a good question. Try to solve it. Even more interesting question. See what you can do here. If a light ray from a medium having n is equals to 1, n is equals to 1 to medium n is equals to root 3. Okay, this complete sphere that is represented here, this is what n is equals to root 3. As shown, find the angle of deviation. You have to calculate the net angle of deviation. Firstly, let's see what kind of ray diagram, rough ray diagram that we'll be having. You are going from rarer medium to denser medium. This was the original path. Correct? Now, if this was the original path, you are going from rarer, this was the original path, and how you'll be drawing the normal. Normal will always be perpendicular to the surface, or normal will always be perpendicular surface. That means it will be like this. Here it is drawn the normal also. Now, rarer to denser medium, bending is always towards the normal. Bending is always towards the normal. That means bending will always towards normal. This I will name as R1. Now, can you say again reflection will be happening? Because it is not a single reflection. This is what 2 reflections will be happening. Just understand the question. So I can say I will draw a normal again. So I will draw a normal again. Now this will be what? Now this will be behaving like this R2 I am naming. This is going to behave like now new angle of incidence. Now finally again it will, now it is moving from denser to rarer. Denser to rarer, that means it will bend towards the normal or away from the normal. This is the normal path that was going. This was the normal path that was going. So it will bend towards the normal or away from the normal. It will bend away from the normal. It will bend away from the normal. This is called as what? Let's suppose I am naming it angle of emergence. So I have to calculate everything. But I have drawn the ray diagram so that I can have basic idea. Can you show the deviation also in the same diagram? Yes, sir. I can show the deviation. How I will be showing? See, this was the initial original ray. Now, but it bent by some angle, and this bending is called as deviation, and I will name it deviation 1. Here, again ray was going like this, but it have bent its path. So again some deviation is coming, and I will name this as deviation 2. Correct? And here what I will name? Who is greater? Angle of incidence is greater or reflection is greater? Incidence is greater. So here I will name I minus R, and here what I will say? I will name E minus R2. E minus R2. So I have created the basic outline of the question. Now I just have to apply the things, and I will simply calculate it. So let's see what is the values are telling you. Apply Snell's law at this point. First reflection. What you will be writing? Tell me in the comment section if there is any lag. Apply Snell's law at this point. First reflection. What you will be writing? Tell me in the comment section if there is any lag. So लाइव चेक करो. क्यों नहीं लाइव में तो आई गेस कनेक्ट हो गया. हाँ चल रहा है. लाइव चेक करो. वापस से चल रहा है. इसको पेज चेंज करो जरा. कर लो एक सेकंड से. नहीं कर दो. So we are live back again. There was actually some technical glitch, that's why. So we are live back again. Fine. So we are good to move again. Sorry for the glitch. So let's see the question again from the starting. Okay, because there was a glitch coming. So I think so some students have missed that portion. So let's see the question, understand completely. What I was telling you, that there is some angle of incidence here. What will be happening? This is the normal that is drawn here. Now what you will be doing? It will have two options. This is the normal path that you are having. This is the normal path that you are having. Now when you are moving from rarer to denser medium, you have two options. Rarer to denser medium, that means bending will be towards the normal. So bend the rate towards the normal. Bend the rate towards the normal, and this angle will be calculated as what? R. Now can I say again a reflection will be happening? That means draw a normal here also. Draw a normal. Now again a reflection will be happening, but this time it is moving from denser to rarer medium. I was explaining you just a moment back. So it will be bending. This is the original path. Now tell me, you will have two options, either towards the normal, either away from the normal. Kidhar jaoge? Denser to rarer medium, that means bending is away from the normal. Denser to rarer medium, that means bending is away from the normal. And this angle will be calculated as E, let's suppose, and this will be behaving like angle of incidence 2. That means let's name this as R2. Now I have created one more thing. You have to calculate how much the deviation is also coming. कैसे लिखोगे deviation? At the first surface, how will be writing? This was the original path, but this are bended by this much of angle. So I'll be writing this as deviation 1, and deviation 1 I will write greater minus smaller. Who is greater? I will say simply I is greater minus of R. या तो directly formula याद कर लो, या तो दिमाग लगा लो. Both are the options. Second point. Here is the original deviation. Here is the original ray where it was moving, but it have bent by some angle, and that bending of angle is called as deviation. And here what I will be naming, I will be writing who is greater? E is greater, E minus R2. Now I have created the complete basic outline, and now we are going to solve this question. Just now we have to solve the basic values we have to calculate. See, what you will be writing? 1 into sine of 60 is equals to n. N is equals to how much? Root 3 sine of R1. Let's name this as R1. So we have to firstly calculate what is R1. क्या लिखोगे? Sine of 60 is how much? Root 3 by 2. Root 3 cancel, and here it is 1 by 2. That means R1 can be written as R1 is equals to 1 by sine of R1 is equals to 1 by 2. That means R1 is equals to 30 degree. ये कितना आया? R1 is equals to 30 degree. R1 is equals to 30 degree. That means from here I can say what? That deviation 1 is going to be equal to I is equals to 60. This is 30. That means deviation 1 is equals to how much? 30 degree. Deviation 1 कितना आ गया? 30 degree. And in which sense of rotation? In clockwise sense. Okay. Now let's calculate what is going to be deviation from the second portion, second refraction. So let's calculate for this one also. Firstly apply Snell's law. Before that, tell me what will be R2. Can you calculate R2? This is a very good question. How will you be calculating R2? This is R1, you know. This is R2, you have to calculate. कैसे calculate करोगे? Anyone? I will say if this angle is 30 degree, I can say that this angle is also nothing but equals to 30 degree. Reason from the basic classes you are remembering that this distance is what? Radius. This is also I can say radius. If this side and this side are equal, angle opposite to them are also going to be equal. Basic property of a triangle. So this is also 30. Now apply Snell's law. What you will be writing? 30 into sine of, sorry, here you will write refractive index Ni, that is root 3 into sine of 30 is equals to, and here it is air, that means 1 into sine of E. Sine of E will be equals to, sine of 30 is what? Half root 3 by 2, that means it is going to be equals to root under 3 by 2, that means E is going to be equal to 60 degree. If E is going to be equal to 60 degree, that means how much deviation is going to come? Deviation is E, that is 60 minus R2, that is 30. Deviation is going to come as 30 degree. That means net deviation, if someone is asking, you will be saying deviation 1 plus deviation 2. How much deviation 1 is, sir? Sir, deviation 1 is 30 degree and deviation 2 is again 30 degree. That means how much the net deviation is going to be? 60 degree. Clear? समझ आया? This is a very good application of Snell's law and angle of deviation. This, if this is clear, that means you can understand the complete Snell's law. Okay. So it was a good question, good conceptual question, that I will say. It will make the concepts very clear for you. Now let's come to the one of the most interesting and one of the most practical concept of the application of refraction. See, you also have observed it. If I will tell you from the example, let's suppose you are taking a container in just down your eyes, okay, just exactly down your eyes, and put a coin into that. Put a coin into that, and now try to observe carefully. Do you have ever observed that coin is looking a bit closer to you than actually it is? Actual distance is maybe it will be larger, but when you will be observing it properly, it will be looking like it is a little bit closer to your eyes. Correct? How that is happening? Actually, that is happening due to the phenomena of refraction. Let's understand the complete thing. Today we are going to prove why why it is looking like that. So everything we are going to see here. See, let's start. Dekho, here is a coin kept. Okay, here is an observer. Here is an observer. So I am going to derive two rays, because for forming any image I require at least two images. So one image I will be taking directly, and this is the surface at which reflection will be happening, and I can say this is the normal. If angle of incidence is 0, angle of reflection will also be 0. Snell's law bhi laga lo, check kar lo. So it will be directly without any disturbance. It is going to pass like this. Correct? This is going to pass like this. Now what will be happening with the second ray? I have taken a different ray at some angle. Okay, I have taken at some angle. Can you say this will be behaving like my angle of incidence for this refractive surface? Now I will have two options. Either I can go towards the normal, either I can go away from the normal. This is the normal incident ray. So I am going from denser to rarer medium. If I am going from denser to rarer medium, bending is away from the normal. That means bending will be away from the normal. And this angle is called as angle of refraction. This angle will be called as angle of refraction. So if I am going to converge this point, this is never going to converge. That means it will form a virtual image, and where that image will be formed, when you will subtend this, actually these two rays appear to converge at this point, and this point will be forming the image point, because the converging point or the intersection point of two reflected rays will be called as point of image. So this is the point of image that you will be having. Okay, so can you say actual object is kept here, but the image for you are watching from here, you are watching just from the upright, you will be feeling that image is looking actually closer, and I can say yes, image is actually there is closer. And this shift that you are getting, this is called as apparent shift. This shift that you are having is called as apparent shift. This depth, complete depth, that is represented as d, the actual depth from this is the reference surface. All these things are calculated from here. So this d is called as real depth. This is called as real depth. This d dash is called as apparent depth. This is called as apparent depth. That means not the actual depth. This is called as apparent depth. That is appears to be. Okay, because the image is forming closer to the actual surface. So now let's enter into the quantitative analysis. How much quantitative analysis, what you can do. So you have to do some construction. This distance is given as x. Okay, let's suppose you are extending it, and here you are making a right angle triangle, and this angle is your I. So tell me firstly, what is tan of I? You can say, what is tan of I? You can say tan of I, if I will ask you to define, you will be writing, sir, it is x divided by the perpendicular distance, that is given as d. That is given as d, because this perpendicular distance is given as what? D. Correct? Very good. Now I have to take a different pen for writing on it. Second one, because it is water. Now I will define tan of r. How I will be defining, sir, tan of r? If this complete angle is r, now understand the angles properly. Can I say this angle is completely also r? This complete angle is also r. If this angle is r, I will drop a perpendicular from here, and this triangle I am focusing. This triangle I am focusing. Tell me what you will be writing tan of r. Again, perpendicular upon base. What is perpendicular? That is x. And what is the base? That you will be having, base is equals to d dash. D dash. Base is equals to d dash. Now what you will be doing? Now take the ratio. What we'll be having from here, that x and x will be simply get cancel out. So do the cancel out, and what we'll be having here, it will be d dash divided by d, and here what we'll be getting, tan of I divided by tan of r. What will be having, tan of I divided by tan of r. Now further when you will be solving it, make it convert it into sine of I divided by sine of r, and here do it what, cos, or again sine of I divided by sine of r. What is the result that you will be having? See here, when we will be putting all these things, because you have to apply Snell's law also. Apply Snell's law at this surface, you will be having a relation of sine and sine of angle of incidence and angle of refraction. After having that relation, you will be having this term tan of I is equals to n1 tan of I is equals to n2 tan of r. And when you will be solving all the complete things, the final result that you have to remember, this is the complete derivation that is provided for you. For your board perspective, you have to remember this complete derivation. What is the final result that you will be writing here is, how this formula you have to remember, that I am telling you. You will be writing apparent depth, or the thing that I have represented as d dash is equals to real depth divided by n of incident medium divided by n of refractive medium. It is defined as apparent depth is equals to d dash is equals to real depth, that is also represented as what, d divided by n of incident medium divided by n of refractive medium. I am telling you, please remember in this way only, otherwise you will be a lot confused that what is n1, what is n2. You will be a lot confused. Okay, so remember, either if you want to remember in different way, there is one more way. Write n from to 2, like from where the light is coming and where the light is going. Remember in this way. Otherwise, if you're remembering this in terms of n1 and n2, I'm telling you, whenever the values will be reversed, now you are going to only get confused. So don't try to remember the values in that way. Please remember that it is simply apparent depth is equal to real depth divided by refractive index from incident medium to divided by refractive index of the reflective medium. Correct? Let's apply some on this on the formulas on the some problem. Here is a very beautiful question. See how fun this question is going to be, and all the concepts will be clear here only. See, what is the question? At a height of eagle is there, and actual depth of the from the free surface of the water are, all the depths are given. Here the fish is there, and here is an eagle is there. Okay, the depth of the fish is 36 meter and the height of the eagle is 24 meter from the surface. This is the reflecting surface, because obviously water will be acting as a reflecting surface. And the refractive index are also mentioned. N is equals to 1, that is air, and N is equals to 4/3, that is water simply. Okay, but the question is, what is the height of the eagle as viewed by the fish? What is the height of the eagle that is viewed by the fish? That means, tell me, who is the observer? Observer is the fish, and who is the object? Object is the eagle. Object is the eagle. Okay, now let's see how I can find this apparent depth. Everything will be clear here. I'm going to derive it again from the basics. I'm going to again draw the complete diagram, and let's understand. Okay, there is no hurry. Object, that means rays will be firstly coming from the object itself. Okay, first ray I am taking from the object, and I am taking at angle is equal to 0. Angle of incidence is equal to 0. That means angle of reflection will be 0. That means it will simply pass it, and it will reach to the eyes of the fish, because this time observer is what the fish is. Okay, take some second ray at some angle. I have taken at some angle. Okay, like this. Now what you will be doing? This will be behaving like angle of incidence. This is going to behave like angle of incidence. Now you will have again two options. You are going from rarer to denser medium. When you are going from rarer to denser medium, what you will be doing? Bending will be towards the normal, away from the normal. It will be bending will be towards the normal. So this was the original ray, but it will bend towards the normal. It will bend towards the normal, and this angle will be calculated as angle of refraction. Correct? Now, is these two rays are ever going to converge? No, they are never going to converge on this side. So if I will subtend this ray, and I will subtend this ray, I can say this is the point of intersection for both these reflected rays, and I will name this ray point as image point. That means for the fish, here is the actual eagle, but it is looking farther from the actual eagle, and this distance is called as what? D dash. This distance is called as what? D dash. D dash is what? Apparent depth. And this distance that is given 24 meter, this is called is equals to D. That is what? Actual depth. How much actual depth is there? So now let's quickly calculate. D dash is equals to real depth, that is D, divided by n of incidence. I have told you n of incident divided by n of refraction. See, incident medium is 1 divided by n of refractive medium. What is refractive medium? That is equals to 4 by 3. That is equals to 4 by 3. That means how much D dash is going to come? D is equals to 24 divided by, here it will become 3, here it will become 4, cancel, it will become 8, and the answer will be coming, that is equals to 32. That is this D dash. D dash is equals to 32 meter. D dash is equals to 32 meter. The distance of the image from the surface. But still the question is not solved. For the fish, how much the distance will be? Because this is what you have calculated from the surface. But the question is asking you from the fish how much the distance is. So what will be saying the final answer? Answer will be quoted as this apparent depth, that is 32 meter, plus this distance, that is this is at 36 meter, 36. So answer will be 68 meter will be the final answer that you will be quoting. समझ आया? It's clear. Very beautiful question, very good application of apparent depth, and if it is not clear in this case, then it is never clear. I'm telling you, this is the best question that you can have for understanding purpose of it. Is a very practical question. You can relate also at your home. If you want to see, you can do it. Now let's come to the second question, second part of this same question. Let's see to the second part of the same question. Second question is the depth of the fish as viewed by the eagle. Now this is the same case as the previous one. I have told you. Who is the observer? This time eagle is the observer. And who is object? Object is the fish. Again I am explaining. Now this is the third time I am explaining the same thing because it is important. So try to understand. Object is the fish. That means some rays will be coming from the fish. First ray I always take as simply pass straight away. Okay. Second ray I will take at some angle. Now I am going from denser to rarer medium. This is the natural ray that should be there, but I am going from denser to rarer. That means bending will be away from the normal. It's away from the normal, and the intersection point is called as image point. That means for eagle, this is the point where it will be feeling that fish is present. Now let's calculate. And what is the terms that we define? This is called as D dash. This is called as D. I will be calculating D dash. Now calculation. D dash will be calculated as D divided by n of incident medium divided by n of refractive medium. D is equals to what? Real depth, that is 36, that is 36, divided by n of incident medium, that is 4 by 3, divided by n of incident refractive medium, that is 1. Now here how much it will become? 36 divided by 4 into 3. Here it is 9 into 3, that is 27 meter. 27 meter. This will be the apparent depth that you are going to get. But it is not the complete answer. Complete answer, if you have to get quote answer, you will be writing 27 plus of 24, that is equals to 1151 meter is the net answer that you are going to write. 51 meter is the net answer that you are going to quote. Okay. Is it clear? Apparent depth, when we are calling real depth, even we have seen everything by the ray diagram. Ray diagrams also prove the same thing. Okay. If you are having sometime, let's suppose for a moment, if you are having the answer is negative, let's suppose apparent depth, depth will be having positive. But if let's suppose someone asks you, tell me what is the apparent shift? What is the apparent shift? How will be saying apparent shift? Apparent shift will be simply calculated as total depth, that is 36 minus of 27. 36 minus of 27, how much it will become? 9 meter of shift is coming between the distance of object and the distance of image. So be very specific, read the questions properly, what the question is asking you, and according to that, then quote your answer. Clear? Formulas also I have told you properly. Here it is 51, one answer is 68. Complete solution is also given, 3 diagrams. Fine. Is it clear to you? Now let's understand how much shift will be coming due to a slab. Due to a slab, how much shift will be coming. So let's see the case of slab, very interesting case. In slab, what the only change will be coming? Till now we have only one plane surface, and due to that one reflection was happening. Now what will be happening? It will be happening two refracting surfaces. Slab, all of you have watched in your colleges, I hope, that slab is a refracting surface, two surfaces are there. So now we are going to analyze for two refracting surfaces. Let's see how we'll be deriving the results. Okay, see, this is the object. Firstly, this is the object, and this is a sort of ray diagram. It will be going from rarer to denser medium. That means this is the original path, this will be the normal. That means it will be bending obviously towards the normal, that means here the image I dash will be coming. Okay, this is the basic ray diagram. And then after that what will be happening? Again this will be the normal, going from rare, this will be the normal ray that should be going, but it is going from denser to rarer medium. That is, it bending will be away from the normal. If bending is away from the normal, it will bend like this way, and it will subtending this, it is going to converge at this point. This will be the final image position. Correct? So all these things I have to calculate. Firstly, due to the first refraction, this is the first surface, how much the apparent depth will be coming? Let's calculate that. Can you say this will be the apparent depth for the image of first image? How will be writing? D dash is equals to D. What is the actual depth, students? Actual depth I am giving you as x divided by n of incident medium. But incident medium is air, that means 1, divided by what is the refractive medium? N. That means D dash can be said as n times of x. Is it clear? How much this distance you will be called as? N times of x. Clear right now? Fine. Now come to the second reflection. First reflection is done. Now come to the second reflection. This is the second surface that you are having. I want to calculate how much the net shift that is coming, and that is called as, this is the net shift that is coming, and I want to calculate this shift. This is also called as normal shift. They are also called as normal shift. This normal shift I am interested in calculating after two reflections. What is the distance between the object and the final image? Correct? This is what I am interested in. So let's apply again the shift that is coming due to the surface 2. Batao. Again the shift I have to write. How I will be writing? Again I will be writing D dash is equals to. Tell me what is the real depth. Firstly tell me what is the real depth. Now I will be calculating everything from this surface. From here to here, this distance is nx. Now because this is going to behave like your object, na? It is clear. The result, the image from first phenomena is always taken as the object for the second phenomena. So I will be taking this as nx plus, what is this thickness? T. So I have written this complete distance, that is the real depth. Now divide by n of incident medium. For this incident medium will be what? N. This is the incident medium divided by the refractive medium, divided by 1. There is no need for writing. So what I will be naming as D dash. D dash will be equals to x plus of t by n. D dash will be what? X plus of t by n. This is what I have got. That means if I have to quote this complete distance, that is the final image here I have drawn. Please see the distance very carefully. This will be written as what? X plus t by n. This will be written as x plus t by n. Clear? Fine. So I have mentioned all the distances, but at the end what I have to calculate as a point of observer, that how much my shift is coming between the object and the image. Tell me a formula that I can remember so that I can solve all the questions directly, because all the time I'm not going to apply both the two times. I will not going to perform this refraction. Okay, this is not possible for me. So I want to combine both these phenomena, and I want to see a normal result. So I have to calculate this distance. Tell me, if I have to write the object distance, how much the object distance is there from this point to this point? This distance. This is x and this is t. That means I will say x plus t. So if I have to write the normal shift, I will write this complete distance, that is x plus t, minus of what is the distance of image from here. This distance I have already told you, this is x plus t by n. X plus t by n. Now see what is the result is coming. Can I say x will be simply get cancelled out, and here it is what? T minus t by n, or you can take it common as well. So it will become t common 1 minus 1 by t into 1 minus n. But if in general, because this 1 is the refractive index of the medium, so it is how it is actually defined as. In general, what you have to remember, it is defined as normal shift is equals to t 1 minus n of surrounding divided by n of the slab. This is what you have to define for the normal shift. This is what you have to define as normal shift. This is the standard result that you have to follow. Derive this thing by yourself. Until unless you are not writing every single distance by yourself by pen and paper, it will never be going to be clear. Okay, so derive everything by yourself, then understand what is the result that you are having, then only you will be gaining some confidence. And after that, it is very simple that you have to just apply the formula. Now let's quickly check the application of this formula. Here the complete derivation is also given for you, so you can take the formula. This is the in general formula, T1 minus n of surrounding divided by n of slab. That is the shift that you will be having. Let's quickly apply this formula into the questions, and I have to tell you something else also. So that's why let's see what is the value is coming. Find the shift from the slab in the given scenario. There is a slab, there is an object. If you'll watch, it doesn't matter you are keeping the object. What was the distance? X. In the final result, ever you have seen that there was any presence of X? No. That is a very important thing. Actually, if you'll notice that doesn't matter if where you are keeping the object from the slab, because only it depends on the refractive indexes of the surrounding and the slab, and only on the thickness of the slab. Correct? So let's see what is the normal shift is coming. Normal shift you will be writing thickness, that is 15 centimeter, 1 by n of slab. Sorry, n of surrounding. Surrounding is air, that means 1 divided by 1 of slab. 15, here it will become 1.5 minus, it will become 0.5 divided by 1.5, 3, cancel. Normal shift will be coming 5 centimeter, and it is coming plus of 5 centimeter. Now see, what is the interpretation of plus 5 and minus 5? That is what I have to tell you. Plus 5 means, if I were to draw the ray diagram, it will be somewhat like this, and there it will be going, just last case we have drawn. So plus 5 always reflects that shift is always coming in the right side. Or I will say it in the proper ways, I should say like shift is coming in the direction of incident ray. Shift is coming in the direction of the incident ray. Clear? Now what will be happening when if it is negative? This question solve. Here is a ray diagram that already I have been drawn. Check here what is the normal shift is coming. Again 15 you will be writing 1 minus n of surrounding. Surrounding this time is not air, it is given as 2, and what is the refractive index of the slab? It is 1.5. So now take it 15, 1.5 minus of 2, that means it will become minus of 0.5 divided by 1.5. Here again it will become 3, again it will become 5, but this time it is going to be equals to minus of 5. If this is equals to minus of 5, what do you understand by minus of 5? Minus of 5 reflects you that shift this time. This is the object, this is the image. Shift is in the opposite direction from the direction for incidence. This is the direction for incident ray. So obviously I will be taking this direction as positive, but the shift is happening in the negative direction. That is the opposite direction from the direction of incident ray. Okay, this is the interpretation of simply as positive sign and negative sign. One more case that in this kind of questions that I have to tell you. Let's suppose multiple slabs are there. Multiple slabs I have connected. Sir, what I will do now? Nothing. Because I have told you it doesn't matter from the distance of object and the eyes or the observer that you are watching, or the distance of even of the slab. So it doesn't matter how much the distance you are keeping, how much it is 10, 20, all these things are irrelevant. Just simply solve it. Three slabs are there now. That means shift will be coming due to 3 slabs. Simply I will calculate. See how to solve this question. This is the last variety of question that I have to tell you. Here it will be writing what? Simply thickness, that is 15 into 1 minus surrounding is air, simply 1 divided by 15 plus second case. What is the thickness here for the second one? 20, 1 minus 1 by 2 plus 30, 1 minus 1.5, 1 divided by 1.5. Now just calculate it simply. It will become how much? 15, 1.5, it will be 1 by 3. That means here the shift will be coming 5 centimeter. Here it will be coming how much? 2 minus 1, and it will become 1. Here it will shift will be coming, that is 10. Solve kar lena khud se. Here we will be having how much? 30, 1.5 minus of 1, 1.5, that means 0.5 divided by 1.5. It will become 3. That means again shift is going to come as 10. 10 plus 5. How much the complete shift is there? 25 centimeter. Doesn't matter what is the distance. So बढ़ा के कर दो 100 centimeter. Still the things will be same. Okay. So the shift will be, net shift will be coming 25 centimeter. Just calculate individually, one slab, second slab, third slab. in normal shift, normal shift, normal shift, add up and just quote your answer. Is it clear? Was it interesting? So as of now, we are keeping for this lecture till here. In the next lecture, again, we are going to see some cases of this. One more case of lateral shift is there when, as of moment, your object and your observer both are in the same medium, air. But what will happen if I am changing this medium? All these things we are going to understand in the next lecture. Until next time, keep learning, keep growing with Tapasya, Endigo, and then Digo, Nama Tapasya.